Alright, what we're going to be doing with this particular lab is we're going to be doing some work dragging an object up a ramp, and we're going to find out that the energy that the object gains is equal to the work that's been done. Pretty straightforward. You're going to go to this simulation right here, so I'm going to go ahead and pop this guy up. I highly recommend that you make it full screen by clicking on this. It just makes it a little bit easier, but since I'm working on just a portion of my screen, I'm just going to begin it right here. I have you select a mass. I'm going to select a different mass, that way you can do something a little bit different. And I'm just going to have you do it for a couple of different angles. For all of these guys, what you should see is the work that's been done is equal to the gravitational potential energy that this thing has gained. So what you're going to do is you're going to run the trial right here, and you're going to figure out how much work that's been done. Remember that the work that's been done is the force multiplied by the distance. So you can see the force right there, and you can use this scale right here to figure out what the distance is. Now you need to use this same exact scale to figure out how high this thing went, so use a piece of paper or something like that and just kind of figure out how much that distance ought to be, and then use the same exact scale to figure out the height that it was raised by. Pretty straightforward. Work is force multiplied by distance. Then you're going to calculate the potential energy, mass times gravity times height. And you say, wow, gee whiz, look at that, they're the same. If what you calculated is not consistent with the law of the conservation of energy, then you know that something bad probably happened. All you're going to do is you're going to repeat this lab with angles of 50 degrees and 90 degrees, leaving the mass the same. So this lab is relatively straightforward.